probably the biggest confusion in this is that there are two different definitions of climate. One of them is planetary climate. So you have people working in planetary physics, and they want to distinguish the climate of the Earth from the climate of Mercury, from Mars, from Venus, so on. These are big differences in some mean temperature. There'll be differences of 100 degrees, 20 degrees, 30, very big. And for these purposes, the planetary scientist ignores the details of climate within the planet and is just looking for the large differences between planets. And they often use a one-dimensional model. The second version of climate is within a planet. Now, within the Earth's planet, with the Earth, climate varies from region to region. It is usually things longer time scale than 30 years, as opposed to weather. You have a different climate in the Arctic. You have a different climate in the Antarctic. You have a different climate on West Coast, different climate on East Coast. And when you compare them to this mean metric, which came from planetary science, they look small. And you wonder what's going on. I'll come back to that in a moment. But in any event, it's essential, as I say, and this is just, wait, I'm looking at the wrong thing. Where is the gadget? What did I do with it? Here. Okay. You know, I reflect on I mean, what you find is in this issue, even people who are skeptical of net zero, you know, they end up supporting the narrative, the story. And my point is Goebbels' description of propaganda, where you start with a big enough lie and repeat it. The big enough is crucial. Little lies are very bad for propaganda. Okay, I'm going to only spend a few minutes, so I'm not going to go through all the details. But even the definition of climate is itself wrong. What do you think is the definition that they give you when you see a picture? It is a graph, let's see, where is it? Yeah, something like that. And it looks like there is warming, right? And there are two things wrong with this, or maybe more than two things wrong with this. One, you're supposed to read the scale. We're talking about 1 degree since 1880. And most people will think that is small, and they will be right. But most people looking at this don't look at the numbers and say, wow, it's going up. They don't show you the data points, do you? Okay. So it's 1 degree, let's see. First of all, what is that? Let's go back for a moment. Does everyone know what this is showing? What do you think this is? Is it an average temperature for the globe? Can you average Mount Everest with the Dead Sea? Would that make any sense? No. No, what they have to do here is at each data point, they are looking for the deviation from a 30-year mean. And they're averaging the deviations. And that makes a little bit more sense. but the data points are worth noticing. Here's with the data points. Those black dots that completely cover everything are the data from which you derive that orange line. Why did it look so different? Because this has a scale of plus or minus 16 degrees. And this is the small difference which you then expand and throw away the data. Now, do all those points agree with the mean? No, it's saying almost as many places are cooling as warming. And there's another diagram I have somewhere here. This is the scatter of 30-year running means with the 30-year running mean of that mean they show you. And it's a random scatter. Half of the ones are doing the opposite to varying degrees. Half are sort of following it. Not a terribly useful thing, even in its own terms. But what about its own terms? It is a global mean. Think about this for a moment. What does it mean to define climate globally? Well, for a planetary scientist, it makes good sense. For an Earth scientist, it's saying if Europe is warmer than normal for 2 or 3 centuries in the medieval period, and there's some place that is cooler than normal for 200 or 300 years, that cancels that. The metric you're shown says there was no climate change. Does that make any sense? It doesn't fit the WMO definition, doesn't fit anything. And yet, people accept it. You show people a graph, and they accept that this is climate. It's not. Okay, then the question is, how does the thing work? And for the Earth, climate change, for instance, between an ice age and the present, or between the warm period 50 million years ago and the present, it's only about 5 degrees. But it's not 5 degrees from a greenhouse effect. For observed climate on the Earth, the tropical half of the Earth remains relatively constant. That's the only part that depends on greenhouse to some extent. For the extratropics, the temperature difference between the tropics and the pole are due to hydrodynamic instabilities, the weather systems, you see. They very much determine what the gradient will be. That the way the people wishing to promote alarm talk about this, they say, of course, what happens at the poles is just an amplification of what happens at the tropics. It's not true. The Coriolis force determines what goes on in each half, and you can test it with the data. If I go through here, I might find it. This is just, we'll skip this, trying to explain it. But when all the explanations are finished, you can actually go to the data for the last 100 some odd years since 1880 and check to see if there's polar amplification. And the upper graph, notice the range, it's less than 1/10 of a degree fluctuation. So it's saying there's no polar amplification in the recent warming of the metric they use. And the other 2 graphs are for the globe and for the tropics. And when there's no polar amplification, these should be essentially the same. What we're showing is that the models do not have that process. One can go further, and this is summarizing it, but here we compare the models that the UN uses with the data. And so, for instance, On the left, you see that the polar amplification exists in virtually every model, whereas the observations are statistically zero. You go to the other side, to the right, and you compare models, and these are randomly selected, but it's true in general. At the bottom, you have the observations, and you have the different models. And interestingly enough, every model has polar amplification. Nature does not. Every model has more tropical warming, greenhouse warming, than is observed. It's very interesting. The models are all over the place, which would suggest they're unreliable, but they're reliable in one thing. They all have errors in the same direction. And that is very suspicious. So here we have a situation which I go through details. All the models run much too warm. They try and tune it so the surface is okay. The open circles are the data, and the colored circles are the different models. And as you see, as you rise in altitude, the differences become more and more severe. In any event, that's what you have at the moment. You can use it to study, with Milankovitch and so on. The important thing with Milankovitch is, in contrast to today's picture of global warming, he focused what went on in the Arctic. And the contribution, which sounds a little bit more trivial than you often make it, but it's very important. He understood something about glaciers. Namely, in the Earth, every winter there will be snow in the Arctic. The real question is how much snow survives the summer. So his parameter was insolation at high latitude, 60 degrees, in June. And he argued this was due to orbital variations, obliquity, precession of the equinoxes, eccentricity. And there have been arguments about this. When I was a student, most people disregarded Milankovitch. Then it became more prevalent as a theory. But when the geologists had a major program, ClimeUp, to investigate the last glacial maximum, they became concerned because when they tried to use the Milankovitch parameter and compare it with ice volume, they had similar spectral lines, but they didn't agree terribly well. It is typical of this field, where you have specialists in different areas, that weaknesses emerge from one analysis to another. So there were two young scientists, Gerard Rowe and a couple from Sweden, astronomers, who saw what the mistake the geologist made was. What was the mistake? They compared the Milankovitch parameter with the ice volume. And at first it sounded reasonable, but the young scientist said, wouldn't it be more reasonable to compare the Milankovitch parameter with the time rate of change of ice volume? And then the agreement was almost perfect. And so this, I think, has vindicated Milankovitch. The orbital parameters explain a great deal. That's not to say there aren't questions still in climate, but I think what we've done is understand the difference between the Earth's climate and planetary climate. And if I can wait, good old PowerPoints. But, you know, the conclusion is we're now dealing with a situation globally, politically, where we are confusing planetary climate with the Earth's climate. And on the basis of this stupid confusion, we're going to use it to justify the destruction of Western industry. We're going to demand that billions of the poor remain poor. We're going to prevent the use of fertilizer, perpetuating hunger in the world. We're going to kill cattle in Holland and Ireland and in Australia and New Zealand. And we're going to do numerous other displays of societal insanity. And the question is, what will the future think about this confusion? That's my short summary. If you have questions. The other talk I gave was one which was totally non-scientific, because this issue of climate alarm is totally non-scientific. In America, it arose for purely political reasons as part of the march through the institutions of the '68 generation. And the damage done by that generation is overwhelming in society. What happened was, as I mentioned, almost a neurotic split occurred in America after World War II. After World War II, the first 10, 15 years were periods of immense prosperity in America. And part of that prosperity was, and remember, America was in a depression until World War II. World War II sort of ended the depression. And following the war, between what was called the GI Bill and so on, was a wonderful period where working class people could have an automobile and a house. And what was the response of the elite and the educated, the people at Harvard and so on when I was there, were still an elite. We hadn't hugely increased universities. It was the houses were ugly. The working people had no taste. It was really ridiculous. In general, there was a feeling it was wrong for working people to live well. And this came to a peak during the Vietnam War. During the Vietnam War, working people were serving in the army, and people in college were excused from serving in the army. And instead of being grateful for this, the argument was they were the people who were the good people, that America was evil, that the Vietnam War was unjust, and that you should do everything possible to eliminate Western society, basically. And it was a violent movement. You may not have realized it, but there were Weather Underground killed several people. You had the Students for a Democratic Society. We had a personal interaction with that in '68. It was the Democratic Convention in Chicago. We lived in Chicago, but my wife and I spent the summer in Colorado, and we asked a student to take care of our apartment. When we returned to Chicago, the police were outside watching our apartment. It had been used by the students from from the Students for Democratic Society as a place to stay while they were protesting the convention. We found their mimeographed sheets on how to poison the Chicago water supply and so on. No, it was real and it continued. It's been studied a lot in the US. People understand that, for instance, the march through the institutions was used to change the character of our universities. So, for instance, when I taught at Harvard in the 60s and 70s, conservatives were about 30%, liberals were 70%. But there was coexistence. Today it's 99-1. And that is, the faculty chooses the successors and they pressure just in one political direction. You have that, but the point I'd make is these movements did not just focus on universities. They did not just focus on teachers. They also dealt with philanthropic organizations, and most importantly, they took over the environmental movement. From 1970 on, in America, the Greens were no longer concerned with whales, with species diversity. It was the energy sector primarily. And the crucial thing politically in America, at least, with the energy sector, is it is possible to spend trillions of dollars on the energy sector. Net zero, conversion of electric power are both hugely expensive things. And the advantage for politicians, at least in America, in giving out trillions of dollars is that the people are getting trillions of dollars and they only need to spend 1 or 2% to pay for the campaign expenses of the politician. This just becomes a very unfortunate cycle. We're seeing it now. But as usual with these things, how do you sell it to the public? And just like Stalin tried to sell Lysenko's version of evolution, just as in America eugenics was used to restrict immigration in 1924, you appeal to science. The public believes science is truthful and effective. The politicians don't realize that science is a mode of investigation. It's not a source of dogma. But it is successful. And so by claiming scientists all agree, most of the public who are not aware of science will go along. And so that's done time and again. And that's been what's done with climate. The irony is, when it was first publicly released in the US, the magazine Newsweek had a cover showing the Earth on fire and saying that all scientists agreed. Nobody checked this. The heads of all the major labs disagreed. Hundreds, thousands of scientists disagreed. Most of them had not thought about this. The field was tiny. But that was not what was at issue. You wanted to convince ordinary people who are not scientists, or especially elite people who are not scientists. And this is crucial. Among your colleagues, many of you know professors in literature, or in sociology, or in any number of fields. How many of those people could tell you what the second law of thermodynamics is? Zero. So this is the group that is looking for an easy answer. I think with ordinary people, my impression is they look at something, you tell them it's 1 degree or 2 degrees, and they say, I deal with this every day between breakfast and lunch, and ignore it. But for educated people, they have been trained to please their professor, and they will accept anything, however crazy, and rationalize it. Okay, so that's the summary of my two talks, and I'll turn to the questions now, if you want. Are these the questions that you want answers, Laszlo? I mean, not that I can give them.
The answer is expected from you.
Okay, well, somebody wanted to know how did I feel about the hydrogen program? And let me say two things. One, this is not my area of expertise. But second of all, hydrogen is not a source of energy. It's a transporter of energy. You need to use energy to make hydrogen, and then you use it as a product of a conversion. So I don't see how you can ever save energy by converting energy with energy to hydrogen. I think this is just another, I mean, you know, there are people who want to see how far you can go with hydrogen, but it would certainly never get rid of other sources of energy. Then somebody wants to know about Miskolci's climate theory. And first of all, as I mentioned, I mean, it's taking for granted that the metric used is correct, which it isn't correct. And the metric used is not Earth's climate. And so even if he was correct, it would be irrelevant. He is keeping the same narrative. But in point of fact, he is wrong. Greenhouse effect is real. However, in using it for planetary difference and assuming the Earth is one-dimensional, which I think most scientists would recognize is a stretch, you are essentially confusing the fact. You're leaving out, among other things, the fact that the pole to equator temperature difference is changing, means the flux of heat out of the tropics is changing as you go between warm periods, ice ages, and so on. And the tropics have remained constant through that, almost constant. And so the notion which the alarm uses that nature provides positive feedbacks, because CO2 itself is very weak, but they introduce positive feedbacks from water vapor and clouds which have never been observed. And they put them in the models so that the models get a larger change. They can make the models produce 3 degrees instead of a ½ degree or 1 degree. But then as we see, they get everything else wrong with the polar magnification and the tropical temperature. So, you know, it's an interesting world where you depend on models, you check the models, they're all wrong, and you take the view, we believe the models, we don't believe nature, we don't believe the data, and we're going to make the world go through immense contortions on the basis of this lack of judgment. At any rate, that's with that question, we call cheese. And then the third question deals with sociology. And I'm not sure, I mean, yes, I mean, we are seeing selfishness in the people who are saying, I'll accept trillions of dollars. I mean, you have to understand, Biden passed something called the Inflation Reduction Act. This is very characteristic in America. You give a name to an act that has nothing to do with what it does. So the Inflation Reduction Act has nothing to do with inflation, but it gives $9 trillion for climate. $9 trillion is a lot of money, even today. And politicians need only 100 million for their campaign. And you can do the arithmetic as to how small a percentage the person getting the 9 trillion or the people getting the 9 trillion have to give back to influence the politicians. So there's selfishness at both ends. And I don't think there is much in the way of virtue in it. Now, there are other questions here about chaos. And, you know, the IPCC is worth paying some attention to. It operates, have any of you ever participated in the UN's Intergovernmental Panel on Climate Change? Is anyone here? Because, you know, you probably remember certain things if you did. You have 3 different groups, one dealing with science, one dealing with mitigation, and one dealing with impacts. The only group that is legitimate is science. The rest take worst case scenarios to make stories. When you're on the science part, and you have far more scientists participating than contribute to the science, but you're told you shouldn't be too critical of models, but otherwise, you know, you don't have to say anything wrong, which I thought was not too unfair. So if you go to working group 1, there is no sign about an existential threat. There is no discussion of anything terrible. There's a statement, there'll be warming, this could have a negative effect. How much of a negative effect? Roughly speaking, they feel by the year 2100, the gross domestic product in the world will have increased by 197% instead of 200%. And, you know, nobody is going to go crazy over that. Allegedly, the world will be much richer in both cases. So nobody checks that. In addition, the UN does something very tricky. It has the other 2 working groups making up scare stories, and it has something called the Summary for Policymakers. The Summary for Policymakers is not written by the same people who write the report. Not only that, it comes out 6 months before the report, so there's an opportunity to modify the report to fit the summary. In addition, all other groups are making statements that are alarming. And so you have this funny situation where there are scientists, they are behaving reasonably decently, but you associate the whole report with them, which is not true. The whole report is largely a political document. At any rate, that's where we're at, and that climate may be stochastic. Well, again, if you take the planetary definition, then it's hard to tell whether it's really going to be stochastic or not, because you're dealing with a funny average. If you're dealing with real climate at real locations, that is chaotic, but that is not what you're told, because you're given that funny metric that comes from planetary climate. My personal feeling is that the fact that real climate has a stochastic component is relevant and helps explain why the correlation with the metric used by the alarmists doesn't work, but otherwise doesn't really help you very much to understand climate. You know, some of the problems that remain outstanding deal with paleoclimate. I mean, that's a fascinating area. So, for example, the Milankovitch hypothesis does a really good job of explaining the last 700,000 years. But we know that there were the Ice Age, let us say ice periods, go back about 2-3 million years. And when you get past 700,000 years, they have a different period. So the last 700,000 years is dominated by 100,000 years. When you go back to the earlier ice period, it's 40,000 years, roughly, the obliquity cycle. We don't quite know the answer to that. There are other things. For instance, the theory of hydrodynamic instability is telling you that the temperature difference between the pole and the equator at about 6 kilometers altitude is about 20 degrees. And we observe that. It is about 20 degrees. But the surface is greater than that because of the presence of ice, which does something very strange. It causes the temperature to increase with height rather than decrease with height for about 3 kilometers. So that makes the difference at the surface more. Okay, so now you say, well, ice makes a difference. During the Eocene, the surface was 20 degrees also, so that looked correct. But according to the paleo data, there are periods without ice where the temperature difference is not 20 degrees. And that, if it's true, would contradict our understanding, and that's still unknown. There are plenty of things that need to be done, but I think the main thing is to understand that planetary climate and terrestrial climate are two different things. Let's see, there's one question about Klaus Hasselmann. I don't know what to say about that. I mean, the person asking this question realizes that nobody references him. Where did he come into this picture? And I know Klaus.
Who got a Nobel Prize?
Well, you know,
3
it's
years ago.
interesting. The issue is something that I think some of you realize. For the Nobel Prizes, there is an awful lot of campaigning. It isn't as though people are always surprised that they got it. In many fields, they've been talking to people, campaigning and trying to get it. Klaus is one of them. He was campaigning for years for this, and it was a surprise to everyone when he got a Nobel Prize, because his relevance to the climate issue, if you look at the references in the literature, is close to zero. So I'm not sure what one does about that. But in any event, do you have any other questions?
Certainly. Tehát nagyjából most megválaszolgatta azokat a kérdéseket, amelyek írásban érkeztek, és akkor most kezdődik az élő beszélgetés. A kérdéseket föl lehet tenni, megjegyzéseket magyar nyelven és angol nyelven, és hát valahogy majd megértjük egymást.
I'm Laurent Ferrer from the Technical University of Budapest. I fully agree with you that politics is governing this whole climate issue, and it is really biasing its results delivered by scientists, and also that IPCC reports are biased with the intention to impact the political decision makers. But since we are in such an environment, it is particularly important to keep the scientific rigor when we try to analyze the climate issues. I agree that it's a difficult issue due to this environment. On the other hand, as you also mentioned, locally, regionally, we can observe chaotic behavior of the climate. Regardless how we interpret it, regardless what we say to be the source of this chaotic behavior, it is very difficult to explain it with the activity of with the industrialization of the last some 100 years by the human beings. Still, I think the major issue that we should agree that there are regionally chaotic changes. These chaotic changes are changing the living conditions for the human beings, and human beings should react on that in a way, actively, to let the planet vital for the human beings, to be able to live on the planet. I don't know if you can get my point. So I don't agree with many of the interpretations of the changes, but there are certain changes regionally.
No, we know that. The Bible has that. You think about it, I mean, you know, people have noticed climate change for a long time. When they discuss the flood, when they discuss this, you know, I think there are a couple of things that should be noted. First, people have intelligence. So over thousands of years, despite all the foolishness, we have survived climate change, which has occurred. Two, there are certain things we almost did not survive already. One was the glacial maximum. During the glacial maximum, population of hominids, people like animals, went down from millions to tens of thousands. Why was that?
Which period do you think?
I mean, you had an ice age. The tropics, in terms of temperature, were the same as today.
Yes.
So they were comfortable. And yet the population went way down. CO2 went way down. What is today a savanna became a desert. What was lush became barely a savanna. Food supply was such that vegetable food was almost gone. You could only support a few people on the agriculture that was possible. It wasn't formal agriculture, but just wild. That was the factor that we almost didn't survive. When CO2 went down from 280 to 180, 170, it was within 20 parts per million of a value where all greenery died. And that today, by the way, is the one thing we know CO2 does. The increase in CO2 that we observe has led to about a 15 to 20% increase in the area of land that is agriculturally useful. So from that point of view, nature has been kind to us within limits.
But most recently, the change of the rate of change is increased, and we cannot be sure whether humans can adapt for the changes.
But the question about it is what to do. And if the answer has nothing to do with CO2, then what you do is build up resilience. And we know that. So, for example, if you have an earthquake in California, usually a few people die. The same earthquake in Haiti, and thousands of people die. So, whether you like it or not, wealth makes people more resilient. You can build houses better, you can take care of things better. Our approach to climate today with CO2 is to make people poorer and hence less resilient. So what we're doing today by net zero is guaranteeing when changes occur, whatever the reason, will be less well equipped. This is insanity.
In the question of Dr. Laurent Földvári, the most important thing that he states, stating that the changing climate change and environmental change is much quicker now than ever before. What do you?
Not ever before, but like in the last 200 years. So the rate of change is increasing, and
Well,
I'm not sure if humanity can adapt on that.
Oh yeah. I mean, we see that all the time. There's nothing unusual about it.
I don't say it's unusual,
No,
but
no,
there
but-
has
but
been
I mean,
species
look at
who could
Cali-
not survive
For
changes.
give you an example in the States, the Gulf Coast, Alabama, Louisiana, part of Florida, used to be good for citrus agriculture. When I was a kid, I mean, this is, 1960, it was still citrus. Since then, it's been too cold for citrus. So you stop growing oranges.
Yeah, this is clear. This is clear. I mean, I'm not worrying about the planet Earth.
Yeah.
It will survive.
No, but I mean, so will people. People can move, one. People can grow different things. People are extraordinarily adaptable. I mean, people act as though if you were to make it agriculturally less productive at some latitude, even over 10 years, 5 years, farmers couldn't adapt. That's not true. Farmers are always changing what they grow according to the conditions. I mean, human beings are quickly adaptable. We're not machines that are just incapable of change. So, but this has nothing to do with the current policy.
I agree. So
Yeah.
from this
The
aspect,
current policy is you get rid of CO2 and the world will be better. That's insane.
yeah, I fully agree with that, and this is the reason I am telling that since we are in an environment which is polarizing the opinions, we have to be very careful and very cautious whatever we
Yeah,
find.
I understand that. If I'm not mistaken, I think Orban has taken that view, that one should be cautious, give science its due. The trouble is, the science is being misrepresented. And if people are lying about the science, how do you obey the science? I've often made another point that I happen to think is true, that science itself is a very strange word. It is the only word I know in English, I don't know how it would be in Hungarian, where the science is the opposite of science.
Which side?
Science is a mode of inquiry. The science is a mode of authority. Science is a method of inquiry. It's not a mode of authority.
Tudomány vagy a tudomány? By the way, okay. ask
May I
Richard.
have a comment to this
Yes.
question? Where our colleague said that in the last 200 years there was an obvious change of the temperature. Now one should be very careful with this temperature because the temperature is in physics it's called an intensive quantity.
Yes.
It cannot be added up.
Absolutely.
It cannot be therefore averaged.
Right.
At least it can be averaged because every number is average, but there is no law of physics which applies to such kind of a quantity as
Absolutely. Christopher
global
Essex
average
has been
temperature is a non-physical concept. So that you see this false increase of temperature is completely senseless. It has no physical basis of anything. Instead of that, one could use some extensive quantity like entropy, but that is very difficult to measure. So instead of that, I would suggest to look for the sea level, because the water on the Earth is in 3 phases, and until it is in 3 phases, it's a very good thermostat, keeping the temperature of the Earth more or less constant. Now, and if one looks to the NASA measurements of the increase, sea level increase, it's about 1 or 2 millimeter per year. So 1 meter in 1,000 years. Now, and if you look back to, let's say, 2,000 or 3,000 years, then it was the same. Greek harbors, 3,000 old harbors, are under the present of the sea, about 2-3 meters. So this 1,000 years is 1 meter, is roughly the increase of the temperature, and that is very steady. Even today is the same. So there is a global warming, but it's very modest and it's very stable. So, and that is what you can measure, but that is hidden by this temperature. For example, there was this hockey stick effect. How did that happen? Before that, the number of measuring points of the temperature for this global average was 6,000 points on the Earth. Then they said that that is too expensive to measure and distant points are also measured, so they decreased it from 6,000 to 4,000 to places which were close to airports and therefore internet communication between those points. And then it suddenly went up because of the increasing air traffic.
No,
No?
I don't think so. I mean, with the hockey stick,
Yeah?
the problem with it is worse than that.
Even worse.
Because a statistician, Steve McIntyre, made the obvious point. He finally, through the courts, got the code, the computer code from the person producing the hockey stick, and discovered putting in random numbers gave you a hockey stick. What you see in it is bizarre, and it should really be understood. They use tree rings from a tree called the bristlecone pine.
Yeah.
It mainly responds to humidity and moisture and rainfall,
Yeah.
but you can get a small temperature signal. So they use a few dozen of these. It's not as many as you think. And then they weight each one differently. And they never explain why, but that is the reason why McIntyre could put in random numbers and get a hockey stick coming out.
Okay, so it's
So it's,
still extra cheap.
I mean, here's the issue, I think, and President Eisenhower of the US, when he left the presidency, gave a speech, a parting speech, and he warned against what he called the scientific government complex. His point was correct. In most of the world, the support, the financial support for science comes from the government. And that's okay if the government has no interest in what the answer is. Then it can promote science. But if the government decides it wants a particular answer and only supports the people who get that answer, we're in trouble. And Eisenhower warned about this when he left office at the end of the 50s. And I think this is what one is seeing. So for instance, with my students, you know, I told them, don't work on climate. Choose something else. Because if you question the current story, you will not get funding. You will not get published. So for instance, I was well enough known in my field that the American Meteorological Society did publish some of my papers. The editor in both cases was fired immediately for letting the paper get published. This is a very dangerous situation, but you know, I would never recommend a student working on climate today. They would not get promoted, they would not get published, it would be suicide. But this is not the way science should be.
Excuse me. In addition,
László Kordus.
What will happen, because it's fact, the sea level elevation, some 100 years later, what will happen with New York, with Bangladesh,
Yeah,
and several multi-millionaire people?
absolutely, absolutely.
That
How
is
long is the
flooding.
time? What is the time scale he was saying?
So,
1,000 years,
maximum
1
a
meter.
1,000 years is
Okay,
very-
1 meter.
1,000 years
Yes.
ago,
That's nothing.
Yeah,
1 meter, 1,000.
1 meter in 1,000 years.
no, that's, tell me what New York was like
I
1,000
am
years
living
ago.
next to the sea. I see. There is not a millimeter change in 40 years.
It was 17 centimeter within 100 years,
Yeah.
so maybe 500.
And there is a harbor in Bergen, and the sea level changes the same way in the last 40 years as was in the last 100 years. There is no observable change.
And it's a recovery in large part still from the last ice age.
Okay. So some of them disagree about
Look.
average.
And
A
the
1,000 years
danger-
ago, New York was not New York.
In Holland, you have places where the population and the whole cities are 10, 15 meters under the sea level. It doesn't matter.
Yes, as
Yeah.
well Ritorino Sea.
Huh? And so
Ritorino Lake.
that's absolutely no problem.
So we shouldn't be worried. So read the time scales and the orders of magnitude.
So,
That's the problem. We are talking about a disaster, the apocalypse,
Yes.
which is going to approach within our lifetime. Nonsense. But we are making our adaptability, the capability to adapt to the situation which is changing. Nobody claims that climate is not changing. Climate is changing.
of course.
But we are killing our adaptability by these insane measures we have seen, the cloud there, the Green Deal and so on. They are wasting our ability for something which is not bringing any solution, just a confusion. And they need the scientists in order to underbow their argumentations. We are the taxpayers, and we will not experience any sea level changes and so on in our lifetime. So don't.
I am not worried because my philosophy is different because I am a paleontologist and I am working from 10,000 years, the last 10,000 years, up to down to 280 million years, and from the Carpathian Basin we have several experiences that, for example, in 6-8 million years ago was in savanna in the Carpathian Basin with giraffes, with hyenas, with gazelles, and
Yeah.
and like now are living in the savannas in
Yeah,
Africa.
but what does that have to do with CO2 emissions?
They are disappeared and extinct.
Pardon me?
Disappeared, extinct. And as a possibility
Yeah.
that what will happen with the humans. The humans has a chance to adapt. Understand?
Animals adapt too.
No, not all.
No, not all. We constantly lose species. All through, do we have dinosaurs today?
They are flying the bird.
Okay. No, I mean, that's nature. Nature is dynamic.
Yes, and they are part of the animal kingdom.
We may disappear someday, but I mean, that is not CO2. And you won't change it.
Yes, it's true. It's not the CO2, but are some small changes in the so-called climate, and which looks like very rapidly increased in the last
Yeah, but what
200 years.
the temperature doesn't mean anything. You see,
Yes,
there is
that-
no other proof that there is
Yes,
sudden
I
change.
understand what you are telling about this, and on other
Yeah.
signatures, also, like the helium. And
The sea level is important. For example, on the Mars, there is no water. So the Mars is behaving completely differently from the Earth.
What we started from.
Mhm.
I think there's a big confusion in the terms we are using. Sometimes we talk about the CO2, other times we talk about global climate change,
Yeah.
and sometimes we say global climate warming. If it is change, it does not plus or minus, it can be hectic. Warning, it always says an increase of temperature. So, first of all, when we say that someone is a climate change denier, or he denies it, then we should understand that which aspect is denied of this process. If someone says that CO2 is not the responsible for the source, it is also not accepted by the official scenario, but I would say that we should still focus on the adaptability, on the resilience, whatever is a source in the background, and there's a responsibility for scientists to understand the real source, the real reason behind the processes, to be able to react accordingly to find a solution.
And two of the 3 points you mentioned are true. CO2 has 1 promille effect compared to all other ones. Second, so CO2 is not. The change exists and positive, but very gradual, and it's the same in the few thousand years back. So there is no reason to say that there is any change in it, because there is no. I mean, the NASA data are the same, but the historical data back to 2000 years. So what are we afraid of? Okay,
Well,
so
how shall I put it? I don't know how you deal with an issue that is fundamentally political
no, that's not
when
my
you
thing.
are trying to make it sound scientific.
Yeah.
I'll give you an example, and perhaps you agree or disagree. The temperature metric shows a change, whether you think it's meaningful or not, of a degree in 100 and some odd years. Ordinary people, as you see in the demonstrations in France and Holland and so on, are saying, or in Canada, are saying, don't bother us with 1 degree. So how has the alarmism changed in response to this? You may have noticed that they no longer speak about the temperature. First, they change it from global warming to climate change. then they change it from temperature to extreme weather.
Yeah.
With extreme weather, they get photographs each day from someplace on Earth, because there's always an extreme someplace, that have a dramatic impact on people's emotions. The document, the Working Group 1 science document, has always said they can find no relation between weather extremes and climate. And so the people promoting alarm are assuming you will never go back and check, and they use it. Recently, in fact, yesterday, the New York Times ran an article saying that with warming, there will be thousands of increased deaths. And as somebody pointed out, if you go to the medical journals, they all point out that cold produces 10 times more deaths than warming. So, you know, when you see this degree of lying and misrepresentation and the use of extreme weather, you know you're dealing with a political system and not with science. So the question now is, if science depends on the political system for its support, how is it to behave properly? And it's been obvious, you know, for instance, when Clinton and Gore became president and vice president, the funding for climate went up by a factor of 15. This created a whole new community in science. Climate was a small field, maybe 5 departments in the US, 1 in the UK, and a big one in Leningrad or St. Petersburg today. All of a sudden you hear about thousands of the world's leading climate scientists. This is a group created because the government wanted to promote alarm, and they understood that. No, the degree of corruption is immense. The question is, for scientists, at what point do you say enough? I don't know the answer to that. Because in America, for instance, I don't know if it's true in Hungary, the number of administrators at MIT is now greater than the number of students. And as far as the administrators go, if the government is going to pay for something, they want to do it.
So you don't know the answer. What should we do?
No, I don't.
Well, there are these famous academies. You are a member of the US academies. How is
I
it
mean,
not
with the
possible
academy,
to
by
make
the way,
your voice here?
no, the academy is a disaster area.
Well, there are some
No.
members
I
of the
mean,
academies.
you don't realize the president of the National Academy in the US is a woman called Marcia McNutt. Okay, she had been in our department for a while and then went into government job. What was she famous for? Well, she had been editor of Science magazine before. And what did she do? She actually had an editorial explaining that she would never permit an article that criticized global warming alarm. That made her president of the National Academy.
Sounds too bad.
Yeah, I mean, it wouldn't be a question if things had been rational. The question is, how do you deal with the irrational?
Yeah, but for example, the academy does not depend on politics, at least not directly or not finance.
The Academy elected the guy who made the hockey stick.
Yeah, man.
Now, there is a book by Stephen Koonin, who's a physicist. He's not a specialist in this field. He just wrote a book pointing out, if you read the reports of the US or you read Working Group 1, or any of these things, what do they say? And his point is they never say all these crazy things. And if you look at the records don't support some of it. If you look at extremes, they don't seem to be rising. And so the question is, what do you do if you're told, constantly told, things that are not true?
Kunin's book
Yeah,
was
it's
published-
called Unsettled.
Unsettled. It
Yeah.
was translated into Hungarian. It was published by the Matthias Corvinus Collegium in Hungary. MCC Press
Yes.
published it. So it
Has
is
anyone read it?
I read it in English.
Okay. Yeah, no, I mean, it's perfectly good. I know why Steve adopted this view. It was very interesting. The American Physical Society has a public policy committee, and Steve was chairman of that and held hearings for people who were supporting the climate issue and people who opposed it. And the transcript of that is available online. And when he held that, it was perfectly clear that the scientific case for concern over CO2 was very weak. And so he presented that result to the American Physical Society. The president of the society said he would ignore this. They were going to support the government.
So money makes the world go round.
Actually, Steve Kunin was in Hungary in 1973, had participated at a high-energy nuclear physics conference, had a big and interesting debate between Walter Greiner, who is dead by now, but also famous nuclear physicist. And after that, he became director of Caltech. And after that, he became presidential advisor of President Obama. So that's,
Yeah.
I know him personally well. So,
Yeah,
and he's a completely highly educated scientist.
What about the European Physical Society's white paper about energy policy? Because they have an energy working group, and this working group published a white paper
I can
about
comment on that.
energy.
The problem is that the members of that committee, at least the majority of them, are sharing our ideas here. But in order to make a statement of the whole European Physical Society, you have to pass all other groups, not only the energy group, but every kind of physical branch, and then it doesn't go through. So a completely alike opinion like you cannot be published because the main leaders of the European Physical Society are blocking it.
it's also, there is a human issue. So for instance, in Norway, in an older generation, Norway was one of the world centers in meteorology. And it had people like Arndt Eliasson and Ragnar Fjørtoft and so on, who were very respected figures in the field. In the case of Arndt Eliasson, who I was close to, he was politically on the left. And at the end of the day, that mattered more to him than his science. And he supported, the energy transition, even though, he knew it was not true. The whole confusion with this issue always makes it much harder to deal with. In any event, that's a problem that I think science will have to deal with. And I'm not altogether optimistic, but I think there are two things that will happen that, look likely to cause a change. one, the policies are disastrous. And so they're going to cause great harm, and eventually people will have to say the pain is too great. We're seeing that in Germany at the moment as it deindustrializes in the Energiewende. You see it in Sri Lanka, where the government is overturned because of the fertilizer policy due to, quote, global warming. So that's one area of change. The other area that I think might be less painful would be, if Trump simply decides that the government gets out of that business, then the administrators will no longer be funded out of it. And people will gradually be able to come out and speak honestly about it. I know at MIT I have colleagues who have signed on, who have privately told me, of course we don't believe it's an existential threat. But, if you're still active at the moment, you need that funding.
Maybe Peter Wojcicki, maybe you have a question to all of us. Maybe you have a question to all of us. Tehát van kérdésed mindannyiunkhoz. Mondd el, légy szíves, hogy mire gondolsz.
Én angolul van, inkább.
Nem baj, magyarul.
Inkább mondom magyarul. Szóval én nekem az a mérnök vagyok, nem vagyok fizikus. De az a benyomásom, hogy
Mining engineer.
statikus rendszerek összehasonlítatásáról van szó, amikor a rendszer nem statikus, ha nagy időkről van szó, ha nagy időtávokról akarunk beszélni. Beszélünk valami tudományról, kialakítunk rá valami modellt, aztán 1000 évre előtt megjósoljuk, és 1000 év múlva egyáltalán nem az lesz a helyzet, ami ma. Tehát az egész tapasztalatom az energetikában 1972 óta. Voltak itt mindenféle modellek, csináltak itt millió prognózist, 5-ször annyi villamosenergia felhasználást jósoltak 1980-ban, mint ma. Kipróbáltuk ezeket a modelleket Jázában, Luxemburgban, Ausztriában, és az volt a tapasztalatom, hogy amilyen eredményt akarok, olyat fogok a modellből kihozni, lehet az bármilyen okos az a modell. IBM 360-ban kezdtük, meg a SCL 304-essel, most nem tudja a legkorszerűbb analóg gép sem tud más pillanatnyilag. Ugyanúgy vagyok vele, mint a mesterséges intelligenciával. Nem mondhatom, hogy az nincs vagy nem jó, én is rámegyek időnként, csak okosabb lesz-e? Hát én nem félek attól, okosabb lesz, mert azt tudja, amit beletettek. Attól félek, hogy meg fog jelenni egy drón, itt a teremben is okosabb lesz, mint én is, nem tudom, mit fog akarni csinálni. De attól nem félek, hogy okosabb lesz az a drón, mint az emberiség. Na most hát ezek ilyen témák, amiket talán nem kéne a mai napra visszavetíteni, hanem többet kellene gondolni arra, hogy mit akarunk ma csinálni, hogy a holnap normális legyen. Hogy lehet befolyásolni azt a marketinget, amely félreviszi a világot. Mibe kerül az a sok abszurd gondolat, amit ma beépítenek a tudományba. Nagyon régről van ez bennem, és az utolsó példám, amit nem akarok nagyon elhúzni, 10 éves lehettem. A nagy Szovjetunióban az volt a tudománynak a fő célja, visszainkovizmus mellett, meg egyebek mellett, hogy hogyan lehetne a közép-ázsiai földeket jobban öntözni, hogy több legyen a gyapot, és legyen elég rohannemű. Hát miket találtak ki? Meg akarták fordítani az Ob folyónak a folyását. Hogy melegíteni lehessen Szibériát, miket találtak ki? Olvastam az ottani tudomány, élet és tudomány újságban, hogy 10 centi hosszú pálcikákat kell fölnyomni az ülbe, és azok majd meg fogják módosítani a napsugarának az irányát, gyűjteni fogják az energiát, föl fogják melegíteni a földet. Ez a abszurd. Ilyeneket írogathat akárki, a Nautilust is kitalálhatja, de ez nem az élet. Nekünk meg a kérdésre az a legnagyobb gondunk, hogy a ma szétvert iparunkkal mit csináljunk. Hova tegyük ezt az energetikát, ami ma van? Mibe fog ez kerülni? Milyen hálózatokat kell ehhez kiépíteni, hogy ezt egyáltalán el lehessen viselni? Ezek a nagy kérdések, milliárdos kérdések, amik meghaladják a mai magyar gazdaságnak a teherbíró képességét. Mi meg azzal foglalkozunk, hogy valós kérdése az, hogy a Tuvalu sziget el fog süllyedni. Ennyi.
Why it is more important the question of think of island Tuvalu than to realize the rational energy policy here.
Yes, so the question is
Yeah.
understand what scientists should do. I mean, scientists should make diversity. I'm sorry, there is no other
The
way.
trouble with scientists is they are people.
Sure.
Maybe artificial intelligence will be able to behave better, but I don't. No, the trouble is, if you're a young scientist in America, you cannot survive without either avoiding this topic or going along with the government. And the thing about it is, and I find this slightly encouraging, most of the young scientists I know realize this. It isn't as though they are emotionally committed. A few are. I mean, the issue, like most political issues, has a very strong emotional component. I think it's not in my area, but one has to ask, why do politicians find this issue so attractive? And it certainly, it involves money, it involves power.
Ideology,
They-
yes.
It's-
Let's not talk about politicians. They're
Unfortunately, how do you avoid it?
scientists. Well, you are a respected scientist. for
I mean,
example.
we don't
If,
live.
I mean, if such respected people cannot be blamed, as we are.
No, it would be
Nobody
great.
has been blamed, actually. That what he's saying is
No.
irrelevant because he's not a climate scientist.
That would be great. It would be great. But I don't think it's the way people behave. It is certainly not in America the way the administrative university behaves. I mean, remember, these are not usually, university presidents in the US are not outstanding scientists as a rule. What is the main thing they are judged by? How much money they bring in.
Same as here.
És ezt is egyfajta adaptivitás, csak
Igen. Más.
természethez adaptálódik, hanem a
So we discuss, it's a situation is same here in
Yeah,
Hungary too.
I mean, it's normal.
I don't know it's normal or not.
I'm saying when an issue arises which is beneficial to politicians, it is sold often by claiming science demands it. And in the examples I mentioned, the scientists, for the most part, publicly went along. So, for instance, in the Soviet Union, with Lysenko, Stalin could claim all scientists in biology agreed, and if they didn't, they ended up in the Gulag and on a few occasions dead. So that was a convincing argument.
So I think now in a different period, not 100 years ago. My last question is that what do you think sciences has any knowledges to understand global problems?
Does science have any contribution to a global problem?
Are on this high level has a complexity because the science is a very short
Yeah.
period of the humanity.
Yeah, the answer is interesting, I think, but I think there is an answer. In the US, when there have been difficult decisions as to weapon systems or things like this, they create what they call a red team, blue team assessment. They assign groups to take opposite positions, do the research, see what the best case can be made for each position in order to see what the problems are with each decision. They never did it with climate. But this is one of the areas where traditionally in the US, science has played a role which is useful. You have this, by the way, for the armed forces. You have committees that spend the summer, these would be scientists, discussing various questions from the military. And, you know, it's not a perfect procedure, but it's been useful over the years. We have these things, but they never were used for climate.
You mentioned this is in the defense area, mainly, and maybe space.
Yeah,
But this is at double cost.
pardon me?
At double cost, because you have to feed both sides in order to get some alternatives or let's say
I
some
mean,
points. Some
you're
aspects
hitting
for
an
decision
important
making.
point, which I think may be true, that taking a cautious view costs more. And this is why Elon Musk can run a space program at half the cost of NASA. Yeah, that may be one of the costs, but I think with defense policy, it's not a terrible thing to have these groups like Jason offer some critical assessment. Nobody's saying it's perfect or they always come up with the right answer, but you want to, I think, hear all views before making major commitments and things like that. You still can make mistakes. We're good at that, but it's better.
What would you suggest to Donald Trump? He certainly has certain reservations against this climate history, but what should he do against?
Well, I mean, he's doing something right now which is very characteristic of him. I know that he does not think this is a serious issue. In his first term, he wanted to do something and have this red team, blue team thing. He was opposed by at least two people. One was his daughter, Ivanka, who is very much concerned with global warming. And the second person was the economist Larry Kudlow. And Kudlow's view was not antagonistic. He just felt that Trump should do that in a second term, not the first term.
Mm-hmm.
So now Trump has his second term. It's clear Trump's attitude is do what you want and think about it later. And I don't mean this as criticism. You notice he's getting rid of all the restrictions on fossil fuels. He's getting out of the Paris Agreement. So he does all these things unilaterally, And once the policies are gone, you can have a discussion that is not constrained by the policy anymore. So he's doing it in a way backwards from what one usually thinks about, but I think it's an effective way. And he's doing it with a lot of things like diversity, equity, and inclusion. You can argue about it, he just got rid of it in the government. And, you know, who knows if it's correct or not, but, you know, we had this airplane crash with a helicopter. And it was very typical of Trump. He said he felt that this was due to diversity, equity, and inclusion. Immediately, the New York Times and even some Republican publications said, you know, how can he say this? We don't have the evidence, and so on. On the other hand, it turns out that the pilot of the helicopter was a former aide to Obama and had almost no background in helicopter flight, but was African American and so on and so forth, was a woman. And, you know, it was a reasonable gamble on Trump's part that this was probably not the best pilot of an helicopter. So I don't know, we're working with a different sort of politician. I think he understands the situation. He also has the experience of a first term, which was a horrible term for him in a certain sense. The whole time he was dealing with the Russia issue, which had nothing to do with him. But he did learn, I think, and we'll see if it works. I mean, you know, people are now wondering with the tariffs. I mean, that's rather dramatic. It will increase prices. Does he have a second step that will correct things? I don't know.
Azt szeretném megkérdezni, hogy who has questions, kinek van még kérdése, aki nem kérdezett? Mert akkor időt adunk. Parancsolj!
What should I say to my card players, old friends, who tell me that, oh, in my childhood the summer was very convenient, but now it is very hot. What about climate change? What should I say then?
No, I mean, you're asking, I think, a very good question. I mean, my mother, I mean, she didn't know about it as a political issue, but whenever there was an unusual day, her comment was, I have never seen a day like this in my whole life. People do think that way. I mean, I mentioned the example of the Gulf Coast of the US, where we know that the temperature has been going down. And you ask people, is it going down or up? It's going up. They've been told it over and over again, and we're talking about such a small change that people really don't know, has it gone up or down? I don't know what you say to them, but you know, one of the things is, why should they believe that this is due to CO2? Because there are other places which you can point to on the earth where it's gotten colder. And so, which one is CO2? You know, so if they agree that, you know, the world behaves a certain way, their perception may be correct or incorrect, but when it comes to policy, why pretend you know what's going on and you know precisely what to do and what you happen to want to do is destroy your society.
But keep balance.
Yeah.
Thank you.
And if no more questions,
Okay.
I would have the last question.
Okay.
What would you recommend to our Prime Minister Viktor Orbán and the Hungarian government to do in the climate policy and energy policy?
Yeah. It depends. I mean, you know him in a way that I don't. I mean, we read about him abroad. It's hard to tell who a person is from newspapers. If he believes it is possible, I think he should be encouraged to not impose this on the scientific community so that the scientific community can treat it as a question. In America, they can't treat it as a question. They have to treat it as a correct thing, and their job is to endorse it. I think he would be someone who would appreciate this as bad policy. And if scientists here have the freedom, then the question will be, how does a Hungarian scientist deal with the international community? Because the international scientific societies often have taken a political position. It's difficult, but you know, the president or prime minister of a country has the power to change the atmosphere in science in that country. That could, you know, it's always struck me as a useful thing. I mean, your colleague who is from Norway now, I mean, Norway did something that I always thought was kind of intelligent. It was a small country, and instead of saying we want to compete in physics or larger fields, it chose meteorology. And as a small country, at the time I was a student, it was a place where almost everyone wanted to go for a postdoctoral year. And so by picking a certain subject, a small country could be a leader rather than just a small segment. Hungary, you know, as a country, you know, today, I would say relatively small, has to decide, you know, if you have a student who's going to be a first-rate theoretical physicist, you don't want to spoil his ambition. But if you pick a smaller field and encourage people there, a country like Hungary can become a central player. And that, as a policy matter, is kind of nice sometimes. And even Norway did that with meteorology, and it, you know, for a long time was successful. It didn't go on for a long time, but for a while, you know, my predecessor at MIT studied in Norway. You had Norwegian participants in von Neumann's numerical group. And, you know, I would say its leadership position continued until almost 1970. So, you know, those are policy things that Orbán could do without a commitment to one side or the other. It would be interesting to see. I mean, you have people like Gutierrez at the UN who would scream at somebody who would allow open study. But can anyone take that seriously?
So, if no further question, we thank you very much the
Thank
conversation with you, and tapsoljuk meg a professzor urat.